Welcome to The Explainer. Every day, hospitals manage this incredible chaotic flow of people. But what you might not realize is that behind all that hustle, there's a surprisingly simple digital system keeping everything in order. Today, we're going to pull back the curtain and see exactly how it works.
So, picture this. You walk into a busy hospital. It's bustling, people are rushing everywhere, and you need to be seen. How in the world does the system make sure you don't get lost in the shuffle? Well, the answer is surprisingly elegant, and we're about to see how.
You know, right at the heart of all this controlled chaos, there's a digital system working silently in the background. And get this, it manages every single patient using just two simple but super powerful rules. So let's dig in and find out what they are. So here's the plan. We'll start with a patient's journey. Then we'll get into the two core rules that make it all work. After that, we'll see a step-by-step simulation to see it in action. And finally, we'll zoom out and look at the bigger picture.
All right, first up, a patient's journey. We're going to set the scene here and really get a feel for the core challenge hospitals are up against every single day.
So here's the fundamental problem, right? On one hand, you've got to be fair, first come, first served. But on the other hand, you absolutely need safety, the ability to hit undo on a mistake in a split second. Balancing these two is the real trick. And that's where a couple of really cool concepts from computer science come into play.
Okay, let's move on to our second part, the waiting line rule. This is all about that fundamental idea of fairness. First come, first served.
So this idea is called a queue. And honestly, you already know exactly how this works. Think about it. It's the line at the grocery store. It's the line for coffee. The first person who gets in that line is the first person to get served. Super simple, totally fair, and everyone knows what to expect. And look, the whole process is just so simple and predictable. A new patient shows up, boom, they join the back of the line. The person at the very front, they're the next to be seen. Once they're treated, they're out, and everyone just shuffles up one spot. No cutting in line, no confusion, it just works. But what happens when things don't go according to plan? I mean, we're in a hospital, right? A simple mistake like typing in the wrong information needs to be fixed immediately. A queue? Well, it's just not built for that. For that, we're going to need a whole different kind of system.
Okay, so check this out. If a queue is like a line for a bus, right? First one in is the first one out. Our second concept, a stack, is totally different. It's more like a stack of plates. You put the new plates on top, and when you need a plate, where do you take it from? The top, the very last one you put on. So, this is what we call a last in, first out principle, or LIFO for short. And the reason this is so brilliant is because the system always knows what the most recent action was. It's whatever is sitting right on top of that stack. This makes it the perfect tool for creating, you guessed it, an undo button. So, let's think about a really critical scenario. A nurse accidentally enters the wrong medication into the system. It happens. With a stack, the system can instantly reverse that one single, most recent action without messing up the patient's entire history. It's like having a digital safety net built right in.
All right, now for the fun part. Let's see how the queue and the stack actually work together in real time. We're going to walk through a patient's entire journey from the moment they check in to when they're treated, and we'll even see how an error gets fixed on the fly.
Okay, first up, a patient named John Smith arrives. The system kicks off an add patient action and poof, he's placed in the queue. Right now, it's just him. All right, a few minutes go by and Priya Kaur checks in. The system adds her to the end of the queue, right behind John. The order is perfectly maintained, first in, first out. Okay, now it's John's turn. The system runs a treat patient action. See what happens? He's taken from the front of the queue, and at the same time, a record of his treatment is put on top of a history stack. And just like that, Priya moves to the front of the line.
But hang on, what if a mistake was made with John's record? Someone hits undo. Now watch this. The system looks at the stack, sees that John's treatment was the very last thing that happened, and it reverses it. It pops his record right off the stack and puts him back at the front of the queue where he belongs. Just like that, the mistake is erased.
Okay, so let's zoom out from that little simulation. What's the big picture here? What are the key things we should take away from all this? So, what we've just seen is a system that can do a few really important things, right? It lets us add patients to a line. It treats them in a fair, first-come, first-served order. It lets us undo the last action, and it lets staff see both who's waiting and who has already been treated. But of course, no system is perfect, right? The huge advantage here is how simple and fair it is. But, and this is a big but, the biggest downside is that it treats everyone the same. This basic model has no way of handling emergencies, that whole process we call triage. This is a system built for order, not for urgency.
And you know, this quote really gets to the heart of the matter. The real power of systems like queues and stacks isn't in how complicated they are, but in their incredible foundational simplicity. They are the basic building blocks that bring order to really complex situations.
And that's our explainer. It's the hidden logic of the hospital waiting room. But now that you see it, I bet you'll start seeing it everywhere. Think about your music playlist. That's basically a queue. And the back button on your web browser? Yep, that's a stack, keeping track of where you've been. These simple, powerful ideas are quietly organizing our whole digital world one step at a time.